So hi everyone, in this video I'm going to discuss about skip lists. So it is one of the implementation of a dictionary na ADT. So let's start with this one. Suppose we have a set of keys that are ordered in an increasing manner. So for example, we started with key 12, 23, 26, 31. So assuming that we want to look for the key 31. So how can we look for it? So essentially what we have to do is we can traverse from 12 and then 23 and then 26 and then eventually we find 31. So what if we are going to look for 78? So we have to traverse through the entire na list just to look for the key 78. Okay, what if there is some way for us to skip some numbers or skip some lines? So for instance, we in this another list here, this would allow us to skip two numbers to get to 31 closer, right? So what if we have another list here that would allow us to skip three numbers before we could reach 31. So that would make the search so much faster, right? So that's the idea of skip lists. It allows us to skip some elements in the list. Okay, so here's the formal definition. So a skip list for a set S of distinct key element items is a series of lists. S sub 0, S sub 1, S sub H. So we have here the first list, S sub 0, and then the second list, S sub 1, S sub 2, and then S sub 3. So the H here essentially would be 3, given that we have um, 4 lists here, such that each of the list here, S sub I, contains the special keys plus infinity or negative infinity. And the first list, the S sub 0, contains the keys of S in the non-decreasing order. So in the first na list, the bottom list contains the special keys, negative infinity, and then the positive infinity, and contains all the keys that are ordered in increasing manner. So each list is a subsequence of the previous one. So for example, we have the S sub 1. So we can say that the S sub 1 would be like a subset of the S sub 0. In the S sub 0, it contains all of the keys, but in the S sub 1, we skip some elements. But essentially, we don't add a new element. It should be whatever is in the S sub 0 would also be in the S sub 1, or whatever would be in S sub 1 would be in the S sub 0 rather. Okay, so and then for example in the S sub 2, so in the S sub 2, um uh, S sub 2 elements would be a subset of S sub 1, but it can't be that in the S sub 2 there would be more elements compared to S sub 1. As you can see, as you go up from S sub 0 to S sub 3, the number of elements are decreasing. Okay, so we can say that the S sub 0 would be the superset, which would contain all of the elements, and the S sub 1, we skip some of the elements, but S sub 1 would be a subset of the S sub 0, and the S sub 2 would be a subset or S sub 1 of S sub 1. Okay, again, it can't happen that the S sub 2 would have more elements compared to S sub 1. Okay, while the last na list, the S sub H, contains only two special keys, which is the negative infinity and then the positive infinity. So skip lists are one way to implement the dictionary na ADT. Okay, so what we can do here is store all of the keys, so it would make the searching for keys so much faster. All right. So how can we implement a skip list? So we can implement it with a quad node. So here, the quad node could store the item. And then, which is, as you can see here, the X. And then on the left, it would be the link to the node before it. And then we could also have on the right, the link to the node after it. And then on the upper, so the node before it. And then for this one, the node below it. So also we define special keys that are plus infinity and then the minus infinity, and then we modify the key comparator to